Hello student, myself Nimesh Prabhakar. Welcome to Antenna and Propagation lecture series. In my last lecture, we complete chapter number 3 as per the G2 syllabus. So in that lecture, we have discussed about the antenna parameter. Now we start new chapter, chapter number 2. So in this lecture, we discuss about the dipole antenna. So first we start with the types of the dipole antenna. So mainly dipole antenna is divided into the three category. So the first one type of the dipole antenna is the infinitesimal dipole antenna, or it is also known as the Hertzian dipole. Second one is the small dipole antenna. This is the for the length for the small dipole antenna is between the lambda by 15 and the lambda by 10. And the last one is the lambda by 2 dipole antenna, and it is also known as the half wave dipole antenna. And the length of this dipole antenna is L is equals to lambda by 2. So mainly the dipole antenna is divided into the three categories: the Hertzian dipole antenna, small dipole antenna, and lambda by 2 dipole antenna or half wave dipole antenna. Now we understand the formation of the dipole antenna. We have discussed about this topic, that means how the dipole antenna is we can make the dipole antenna or the formation of the dipole antenna in the chapter number 1. So we have little discussion about the dipole antenna in chapter number 1. Now in the detail we study about the dipole antenna, how the dipole antenna form and how it radiates the energy in this lecture. So the formation of the dipole antenna. The simplest type of linear wire antenna is nothing but the dipole antenna. It is the form using a two-wire transmission line. So we know that the dipole antenna is nothing but the simple linear wire antenna, and we can make the dipole antenna by using the two transmitting line. So here in the figure we can see this is a two transmission line. Consider a parallel two-wire transmission line with a far end open circuit as shown in the figure. So here this is a two transmitting line, and one end is the terminated and the second end is the open. The transmission line has the characteristic impedance Z0, which mismatch with the open end impedance, that means the ZL is equals to infinite. We know that the transmitting line, here we consider the transmitting line characteristic impedance is the Z0, and one portion of the transmitting line is the open end, so it is the mismatch with this transmitting line impedance or the characteristic impedance. So the result of the mismatch is current on each wire. When arrive at the end of each of the wire, it undergoes a complete reflector. So due to that reflection, the standing wave is present in this wire. Now we consider the section in this figure of transmission line between the 0 less than L, 0 less than Z less than or equals to L by 2 is flare as shown in the figure. So here we have just given the flaring in this figure. So in the last figure we have considered simple two transmission line parallel to each other. Now we have given the flaring at the end of the two transmitting line. So then because of the two wire of flare section are not close to each other, the field radiated by the one is not cancelled by the other. So therefore it is result in the radiation. As the flaring is increased, the radiation is increased. So that means here we have given the flaring, and due to that at the one end we cannot is not the transmission, that means the radiation is not cancelled, and the radiation is also depend on the flaring. When we increase the flaring, at that time the radiation is the maximum. Now we consider the third one case. So in the figure, the flaring is done to the maximum extent. That means here we have given the maximum flaring. That means the 90-degree, the flaring we have given. The element of the flare wire are aligned along a vertical line. We can see here the flaring is a vertical line. This system is called the dipole. Note that the parallel horizontal wire on the left of the flare wire are not given any radiation. That means here the horizontal wire we have seen is not given any radiation. But this vertical wire, that means we have flared that wire, it gives the radiation. Only the vertical flat section are responsible for the radiation. Now we discuss about the steps for the analysis of the dipole. So there are the different steps we have to use to analyze the dipole. So first, select appropriate coordinate system and determine magnetic vector potential A. So we have to first select the appropriate coordinate system to analyze any dipole antenna, and then we have to determine the magnetic vector potential A. The next one is to find the value of H from the B is equals to nu into H or delta cross A. Now third one is to determine the E from the delta cross H is equals to J omega epsilon E, or using the intrinsic impedance given by E by H is equals to eta. Now to find the radiation resistance, initially we obtain the power radiated by using the complex Poynting vector as P radiate is equals to W dot ds. So here our goal is to find the radiation resistance. So there is a relation between the power radiate and radiation resistance. So first we find the radiation power, that means the P radiate, by using this equation W dot ds. Well, the W is equals to 1 by 2 E cross L. This is nothing but the Poynting vector. And using the P radiate, the radiation resistance of the antenna is determined by using this equation. That means the relation between the radiation resistance and the power radiate is nothing but the P radiate is equals to I square R. The R is nothing but the radiation resistance RR, where the RR is the radiation resistance of the antenna. So we can find out the value of the RR by using this equation. So first we find the power radiate by using this equation, and then we find the radiation resistance by using this equation. That means the power radiate is equals to I square R. So these are the steps to analyze the dipole. Here the I is also indicate the RMS value of the current through the antenna. So here in this lecture we discuss about the dipole antenna. Now in the next lecture we learn about the different types of dipole antenna. That means first we learn about the oscillating dipole. This is nothing but the Hertzian dipole. Then we learn about the small dipole antenna, and then we learn about the monopole antenna, and last we learn about the half wave. That is nothing but the lambda by 2 antenna or the half wave dipole antenna. So in this chapter we discuss about the different types of antenna. Sometimes question asked in a G2A exam, define the different types of the dipole antenna, or it's also asked in a 7 marks question, write the short note of the half wave dipole antenna, or in a sometime in a G2A exam also asked question in the form of the example, like they have given the data, and from that data we have to find the gain or the directivity for the half wave dipole antenna or the short wave monopole antenna. So many types of question asked from this question. So here In this chapter, we discuss about the different types of the dipole antenna, like monopole antenna, half-wave dipole antenna, lambda. So half-wave dipole antenna is nothing but a lambda/2 dipole antenna, oscillating dipole antenna, and a small dipole antenna. So different types of dipole antenna we will study in the detail and analyze how it radiates its energy by using the different equation. Thank you. Hello and welcome to our channel Electronics and Communication Engineering. Congratulations to find us for learning. You are watching a lecture series on antenna and propagation that has approx 44 sessions and more are coming up. We have more than 1200 sessions in various lecture series on courses for electronics and communication engineering. Watch it and learn. If you like it, share it, subscribe it and press bell icon to receive all updates on new session. Enjoy learning.